Hi everyone, I am Shubham Garg and welcome back to the lecture series of Tanner. So in today's video we are going to continue our previous video, that is we are going to use our NAND gate symbol to generate a D flip-flop. Alright, so let me just show you the schematic of a D flip-flop. So you can see in a D flip-flop we need these 4 NAND gates, that is 1, 2, 3 and 4. These 4 NAND gates are connected like this, and here we have an inverter. Alright, so we have 2 inputs, that is clock and data in. So whenever the clock is enabled, whenever the clock is high, the D flip-flop will start running. Alright, so we have both the things, that is the symbol of NAND gate and the symbol of inverter. So we are going to use all these things to create a D flip-flop. Alright, so without wasting any time, let us start with the symbol and let us create the D flip-flop. So I'm going to delete all the there is no need to delete this. I am going to create first of all a new cell, that is cell new view, or let's create a new library. Okay, so first of all we are going to create a new library, that is the new library's name will be let's say D flip-flop. Alright, so I'm going to click OK. Here I am going to create a new folder, that is D flip-flop, and in this I am going to create a new library, that is DFF. Alright, so here is our new library DFF. So here in the cell we are going to create a new view, and just make sure to select the library D flip-flop. Now we are going to name the cell as D flip-flop, and I am going to click OK. Alright, so we have our new cell. Alright, so from here we are going to take the instance of the NAND gate, and this is the symbol. Okay, don't go with the name that is NAND underscore SYM or something. Go with the view type. Alright, this is our symbol, and we are going to take the instance. So here is our symbol 1. Since we need 4 NAND gates, so 1, 2, 3 and 4. These are our 4 NAND gates. Alright, now next thing what we need to do is we need to add the symbol of inverter. Now if you remember, first of all let us save this. If you remember, in the inverter, when we created the symbol of the inverter, what we did, we let these things remain here, that is our sources were there. So I will just delete these sources, and I am going to create a new symbol for the inverter. So I'm going to save it and create a new symbol, that is cell generate symbol. Okay, and I'm going to click replace. So here is our new symbol, and I'm just going to save it. Okay, so now let's create a new cell view. Let's write inv. Okay, and click it was a symbol type view, sorry. So let's create a new cell view, and that should be a schematic type view, inv. Okay, and this should be a schematic type view, and I'm going to click OK. Alright, so let's just save it, and we can see, so we have this symbol here, and let's create an instance, and let's see. Yeah, so now our symbol is fine. Okay, this is our symbol, and even when we double click those symbol, we finally get this thing. Okay, so we were able to modify that schematic, so now we will be able to use it easily. So in D flip-flop, let's come back to our schematic. Here we have 4 D flip-flops, 4 NAND gates, and here we will be adding our inverter symbol. So there is this inverter, and we are going to take an instance. So this is our inverter symbol, that is right here. Okay, so these are our gates, all the gates. Okay, And now let us start making connections. First of all, we are going to make the connections of ground and VDD. So here these are the miscellaneous. Here this is ground. So I'm going to take an instance. I'm going to attach a ground everywhere. So here for every symbol will be containing a ground. Okay, and now next thing is the VDD. Alright, so VDD is here. I'm going to click on instance, and here is the VDD. Okay, so I'm going to attach one VDD to everyone. Okay, this is our VDD. Alright, so now let's make the voltage source, that is VDC, and this will be in the sources. So I'm going to create an instance for this, and let's put it here. Alright, we will copy the ground, and we are going to copy the VDD. So this is our voltage source. Okay, and now let us start making the connections. So if you remember the circuit diagram, this is how the circuit diagram is. Alright, that is, there will be the input. First the input will be at this NAND gate, and other input will be coming through the inverter. Okay, the other terminals of this NAND gate will be connected to through the clock, and there here will be the latch formation, that is the formation like this. Okay, so this is how we are going to make our schematic. So let us start making the schematic by using this wire. Okay, so first of all we are going to connect the output of this NAND gate to the input of this NAND gate. Okay, similarly the output of this NAND gate to the input here. Okay, let's just use wire like this. Yeah, okay, now next thing is that the final output, for the final output let's just extend the wires. Or let's just delete it. Let's just use the output port here, because there will be a Q output, and below will be a Q bar output. Similarly, we will be having an output port here. Here I am going to name it as Q bar. And just click Alt plus M and move it a little bit further. Yeah, so now just use a wire and make the connections like this. Similarly here also. Like this. Okay, so these connections we have made. Now what we need to do is we need to make these connections. First of all, both of these inputs are going to be connected, which will in turn be connected to the clock. So just give an input here. So here is this input, that is clock. All right, and now we are going to use this clock. Yeah, so now let's just move the symbol here a bit. Okay, so here we will be connecting this inverter like this. Alright, so our inverter is connected, and now let us do one thing. Let's just move clock a bit back. Yeah, here is our clock, and finally we will be having our input, that is data in. So here this is our data in. So I will just write data here, and let's move it, extend it. So this is our data input. Alright, so let's just make the connection, and like this. Okay, so this is how we make the connections. Here we can see this is our output. This one is our output voltage, that is VDC source, These are our NAND gates, all right, and here is our inverter. Okay, so here is our data input and clock. Now we need to give the inputs here. So here let us provide the inputs. We are going to use VBit. Okay, so here we have in our sources, so we are going to search for VBit and let's go to instance. So here is our VBit, and this one is for the data one, and this is for clock. Okay, so now let me tell you one thing, that in order for D flip-flop to work, the clock should be 1. Okay, that is, it should always be enabled. So and when you click on this VBit input, this is the by default pattern, that is, on 0 the clock will get disabled, on 1 it will be enabled. This is some kind of pattern, so we need our clock to be enabled all the time. So we are going to give the pattern as 1111, that is, all the sequences 1. That is all, for all the time we need our clock to be enabled. Okay, so this is how our D flip-flop schematic looks like. So now let's just save the schematic and try to simulate it. So here we have the button start simulation. Okay, yeah, make sure to fill every detail, that is 100 in, here 1 in, and in general include the library files. So now let's wait till our simulation is running. So we can see that our simulation is running. So now let us connect these probes. Sorry, let us connect the plots for voltage print, that is, this is for the input and this is for the output. Alright, so let's just save it once again and let's run. And we can say we have a plot, but it is kind of distorted. All right, yeah, so I guess we have somewhere it gets shorted or something. Okay, so let us see what mistake we have made. Okay, so yeah, our plot is running fine. There is some voltage difference or something in the sources, I guess. Okay, that is our output is coming at this, the lower level is at 2 volts at our output. There is some kind of and the higher level is at 2.5. There is some kind of difference in that only. Okay, basically there is that kind of difference only. So we have our difference in this, that is a higher level here is 2.5 and the lower level is 2 in the output, and in the input the higher level is 5 and the lower level is 0 as it should be. So that is some problem. I guess there is some short or something in the circuit. Anyways, otherwise we can see the pattern that it is working fine as a D flip-flop. That is whatever the data we have given, it is coming back to us. Alright, that's what D flip-flop does. Okay, so that means our circuit is working fine. There is only just issue on this scale that might be due to some short or something. So no worries about that. Okay, so our D flip-flop is working fine. So that's it for this video. And in the next video, what we are going to do is we are going to create a symbol for this D flip-flop. That is, this schematic will be turned to a symbol, and then we will be using these D flip-flop symbols to create a shift register. Okay, that is a 4-bit shift register using D flip-flop. So this is all for this video. See you guys in the next video.